There are two basic kind of loops in MATLAB, the for loop and the while loop. And what you will frequently find is that for simple um, processes within loops, it is if you have a predefined number of steps such that you would be tempted to use a for loop, it is frequently the case that these things can be vectorized and made much more efficient, faster in MATLAB by doing it with a vectorized form rather than using a for loop. Now, of course, if you've got a lot of complex processing going on, multiple steps and whatnot, within a fixed number of steps loop, you may still need a for loop. And so there are certainly places where you need for loops. But if the processing you're doing is very simple, then a lot of times you can just vectorize it. And the second part of your assignment in this module will show that there's a way to do particular processing in a vectorized form when the natural temptation would be to use a for loop. So let me give you the results of what that exercise should be, just so you can know what you're aiming for. And what you can see is that we've got three different curves. One is given by the plus signs. It's a little hard to see, but one is given by the circles, and so those circles are connected in a line. Then you have the plus signs, and the plus signs are in there, but there's a plus sign there, etc. And so you see this sawtooth wave going on. And then finally, you've got the smooth curve that's going on, and over this interval. Now, as you'll see in the exercise, it turns out that all three sets of data were drawn from the same function. And obviously, the point is that when we were creating the circles, we were clearly not sampling the function at a high enough rate to be able to pull out the actual characteristic of the curve. And even with the red sawtooth wave, certainly it's doing much better. Oh, sorry, it's not the red one that's sawtooth. It's the green one that's sawtooth. But certainly it's doing much better, but still not perfect. And you can see that near zero, where the actual function that's depicted in red, you can see has an interesting characteristic there. It's very smooth. It's differentiable, but that's not being brought out with the approximations. And so the major point here, of course, is that when you're plotting out functions, you got to be careful. MATLAB will by default connect the dots, and that can be a very bad thing if you're not plotting with high enough resolution. Anyway, you'll be able to do this exercise with just a few lines of code if you vectorize it. If you do the for loops in order to do this portion, just keep in the back of your mind that's not the best way. You will get some points deducted if you don't try to do this and succeed in doing this with a vectorized form. All right, and then the last part of the assignment has to do with an approximation to the cosine. Let me do help my cosine so we can see what the help function brings up on this user-defined function M file. So it's a Taylor series approximation of the cosine. The input argument is angle in units of radians. We have four output arguments. Approximation is the approximation we're generating this function. Truth is what MATLAB is giving us. Error is the difference between the two, and then a convergence flag to see whether or not the function actually converged. And if we do an example, so true, you'll notice that the values that you set the output to don't have to be what's in the help function, or doesn't have to be the variables that are in the actual function itself. These are just examples. You can give the output any name you want. That's perfectly fine. I'll make it C for convergence. Then my cosine, let's see, let's do pi over 2, because we know that's supposed to be 0. Cosine of pi over 2 should be 0, and see what happens. So the value we get out of the approximation is about 2 times 10 to the minus 5th. MATLAB is giving us 6 times 10 to the minus 17. Obviously the true value is supposed to be 0. MATLAB does a very good job of giving us that. The error is on the order of 10 to the minus 5th. You'll see in the exercise that the error criteria is that it needs to be less than 10 to the minus 4, so we've succeeded, and the convergence flag says yes, we have succeeded. Alright, so that gives you a little bit of an overview of what a couple of the assignments are looking like, and good luck.